Dear students, now we solve question number 23 from the question series of IIT JAM 2024 mathematics question paper. The question is, for alpha belongs to R, the set of real number, let y alpha x be the solution of the differential equation dy by dx plus 2y is equal to 1 by 1 plus x square for x belongs to R, satisfying y of 0 is equal to alpha. Then which one of the following is true? Option A, limit x tends to infinity, y alpha x is equal to 0 for every alpha belongs to R. Option B, limit x tends to infinity, y alpha x is equal to 1 for every alpha belongs to R. Option C, there exists an alpha belongs to R such that limit x tends to infinity, y alpha x exists but its value is different from 0 and 1. Option D, there is an alpha belongs to R for which limit x tends to infinity, y alpha x does not exist. So here the given differential equation is the given differential equation is dy by dx plus 2y is equal to 1 by 1 plus x square for x belongs to R and satisfying y of 0 is equal to alpha. This differential equation is a first order linear differential equation. So here px is equal to 2 and qx is equal to 1 by 1 plus x square, because the standard form of first order linear differential equation is dy by dx plus pxy is equal to qx. So here px equal to 2 and qx equal to 1 by 1 plus x square. So integrating factor is equal to e to the power integration px dx. Here px equal to 2, so integration 2 dx is equal to e to the power 2x. Multiplying the differential equation by integrating factor, we get multiplying the given differential equation by integrating factor, we get e to the power 2x dy by dx plus 2y e to the power 2x is equal to e to the power 2x by 1 plus x square, or dy by dx of y into e to the power 2x is equal to e to the power 2x by 1 plus x square. This function has no antiderivative, so it is not Newton integrable, but this function is continuous in R, the set of real number. So if we take any closed and bounded interval in R, this function is remain integrable in any closed and bounded interval in R. Therefore, integrating we get y of x into e to the power 2x is equal to 0 to x e to the power 2t by 1 plus t square dt plus c, where c is the integrating constant. Now, from the given condition, y of 0 is equal to alpha. So putting x equal to 0, here we get y of 0 into e to the power 0 means 1 is equal to 0 to 0, this function is 0, so 0 plus c, or y of 0 is alpha, alpha into 1 means alpha, is equal to 0 plus c means c. Therefore y alpha of x into e to the power 2x is equal to 0 to x e to the power 2t by 1 plus t square dt plus alpha, or y alpha of x is equal to e to the power minus 2x 0 to x e to the power 2t by 1 plus t square dt plus alpha e to the power minus 2x. Now, limit x tends to infinity, y alpha of x is equal to, this is the solution of the given differential equation. Now we find out y alpha of x as limit x tends to infinity, because in our first option it is said that limit x tends to infinity, y alpha of x is equal to 0 for every alpha belongs to R, and in option B, limit x tends to infinity, y alpha of x is equal to 1 for every alpha belongs to R. So now we find out the value of y alpha x as x tends to infinity. So limit x tends to infinity, y alpha x is equal to limit x tends to infinity e to the power minus 2x 0 to x e to the power 2t by 1 plus t square dt plus limit x tends to infinity alpha e to the power minus 2x. This limit tends to 0 because we know that limit x tends to infinity e to the power minus 2x is equal to 0 as x tends to infinity for every alpha belongs to R. For every alpha belongs to R, this is tends to 0. Now we have to find out the value of this limit. So is equal to limit x tends to infinity integration 0 to x e to the power 2t by 1 plus t square dt by e to the power 2x plus 0 is equal to limit x tends to infinity, it is infinity by infinity form, so by L'Hospital's rule, e to the power 2x by 1 plus x square by 2 e to the power 2x plus 0 is equal to limit x tends to infinity e to the power 2x by 1 plus x square into 1 by 2 e to the power 2x e to the power 2x e to the power 2x cancel, so is equal to half limit x tends to infinity 1 by 1 plus x square, so this is equal to half into 0 is equal to 0. Therefore this limit is equal to 0, and for every alpha this limit is 0. Therefore this goes to limit x tends to infinity y alpha of x is equal to 0 for every alpha belongs to R. Therefore in option A, limit x tends to infinity y alpha of x equal to 0 for every alpha belongs to R. This is correct. And option D, there is an alpha belongs to R for which limit x tends to alpha y alpha x does not exist. This is false, because for every alpha belongs to R, limit x tends to infinity exists and equal to 0. So since limit x tends to infinity y alpha of x equal to 0 for every alpha belongs to R, so this is wrong. And there, since we see that for every alpha belongs to R, limit x tends to infinity y alpha x equal to 0, so there does not exist an alpha belongs to R such that this limit exists and its value is different from 0 and 1, so this is also false. Therefore option A is correct. Thank you.